The next chapter that we're going to talk about is shadows. There are two types of shadows in Maya. One is depth map shadows and the other is ray trace shadows. I'm just going to create a light here, directional light, and if we go to the attribute editor for that light, there's a shadow section here, and just under the shadow section you can turn on use depth map shadows, or you can turn on use ray trace shadows. Now if you turn on use ray trace shadows, you're going to have to go into the render globals and make sure that you turn on ray tracing. Okay, so the first thing that we're going to talk about is the depth map shadows. So let's just go back to the attribute editor and change that to use depth map shadows. Now depth maps are computed as a first pass even before you do your render, while the ray traced ones are computed during the rendering phase. Now what happens is a depth render is done from the point of view of the light and then later used during the rendering phase to determine if that light illuminates a given point. So I'm just going to stow this and we'll look at a diagram. Okay, so if we look at a point being shaded, for instance this blue point, you turn on your use depth map shadows, a square grid of pixels is placed in front of that light and a depth ray is shot through the center of each one of these pixels. And what happens is it goes down, and as soon as it hits a shadow casting object, it returns a depth value or a distance value. And then that distance value is stored in this map. Then it comes time to actually render that point. So we'll look here. And so what happens is the camera is looking at this point. It's trying to figure out, what color it is, also whether or not it's in shadow. So what it does is it does a comparison of the distance that's stored in the depth map to the distance of that light to that point. So it's comparing the distance from the first shadow casting object to up here, okay? And it makes an assumption that if the distance for the point being shaded is further from the light than the stored depth value, then this point must be in shadow. And the reason that it must be in shadow is because something must be blocking it. So there must be something in its way. So the next thing that we're going to talk about is just some of the problems that can happen with depth map shadows because of this simple algorithm. And I'm just going to show you another diagram. This is a self-shadow problem that can sometimes happen. And all I mean by that is just one surface casting shadows on itself. So this area over here is casting shadows on itself over here. Okay, and this is just a regular directional light that we're looking at. So let's go back to Maya. And I'm just going to open a scene. Okay, and all I have in this scene is just a directional light and a plane. And for the light, you'll notice that I have the use depth map shadows turned on. So let's just go ahead and render that. Okay, so this is a problem. This is an artifacting problem that can happen when using depth map shadows. This is a self-shadowing problem. So let's go ahead and just look at another diagram. And let's look at what's happening here. So when we talked about the algorithm of the depth map shadows, we discovered that if the point that we're currently shading is further from the light than the stored depth value, then that point must be in shadow. So if we look here, this dotted line here, so this region right in here, this would represent one pixel in that depth map. So the depth ray comes into the middle of the pixel here, or shoots out from the middle of the pixel, and this is going to be the stored depth value. Okay, so the cast shadows flag is turned on for our plane, and this is the stored depth value. So when it comes time to actually render the points that fall within that pixel in the depth map, If we look at that algorithm again, specifically if we look at the points along here, these points we could say are actually closer to the light than the stored depth value. So these are going to be illuminated. But if you look at the points down here, these are actually further from the light than the stored depth value. So these are going to be incorrectly in shadow. So we have some fixes that can prevent this self-shadowing problem. And one of them is using the depth map bias. So I'm just going to IPR this and just change the depth map bias value, and we can see that very quickly update in the IPR. Okay, so here's a depth map bias, and you'll notice when we start increasing this, the problem's going away. We might have to increase this a little bit more, maybe even more than 2. Okay, so now our self-shadowing problem has gone away. So let's look at what the depth map bias is actually doing. So we'll just stow this again, and let's go ahead and get another diagram here. If we look at the diagram on the bottom here, again, the dotted lines here represent 1 pixel area in the depth map. So this is the depth ray coming down. This is the stored depth value. So if we look at this in terms of whether or not something's in shadow or not, we could say that any points that are going to be shaded here at the rendering phase are actually closer to the light than the stored depth value, whereas the points along here are actually further from the light than the stored depth value. So what the bias does is it actually biases that point closer to the light than the stored depth value, essentially tricking the renderer into thinking that this is closer to the light than the stored depth value and therefore illuminated. So if we go back here, you'll notice that we had to actually move that up quite a bit. The default is 0.001. Whoops, 0.001. Something that you're going to want to be aware of, though, if your depth map bias is too high, what you're going to do is you're going to bias the parts that are supposed to be in shadow right out of shadow. So you just want to be careful. Sometimes it will look like the shadow is actually detached from the object. The next thing that we're going to talk about, or the next attribute that we're going to talk about that will solve this depth map, or excuse me, that will solve this self-shadowing problem, is the use mid-distance depth map. So I'm just going to stop this IPR, and let's just go ahead and turn that on and do a render. Okay, the depth map bias is back to its default. Okay, and there's our plane. You'll notice that there's absolutely no self-shadowing problem there at all. Now, this is actually on by default, but I turned it off because I wanted to demonstrate the self-shadowing problem. So let's just quickly look at what this flag is doing. Okay, so if you look at our sphere again, again the dotted line, these 2 dotted lines represent 1 sort of pixel area in the depth map. This is our depth ray, so this is the stored depth value here. So we're trying to figure out whether or not these points are in shadow or not. So what the use mid-distance flag does is, when we originally talked about the algorithm, we said, okay, the first shadow casting surface that this depth ray hits, we store that value as the depth map value. But what the use mid-distance flag does is it looks at the first shadow casting surface that it intersects. It looks at the second shadow casting surface that it intersects. So it's coming right down here, right to the back side of the sphere, and it takes the mid-distance between them. So now this is going to be our stored depth value. So if we look at any points along here, they're all closer to the light than the stored depth value. So they're all going to be correctly illuminated. Now I just want to mention that when this is turned on, you will actually get 2 depth maps created. And I'll show you how you can actually write out your depth maps to disk. So you will get 2 depth maps, one being the first intersecting surface and the second being the second intersecting surface. So let's just quickly look at that. Just going to get a new scene here and just add a sphere. Okay, and just going to create directional light. Just going to move that out a bit. Okay, and let's just go ahead and turn on depth map shadows. Okay, so the depth maps are actually calculated per frame. So just recalculated as an animation continues. Now, and they're not actually written out either, but if you do want to write them out, what you can do is you can come into the disk-based depth maps and turn on overwrite existing depth maps. Okay, so if we do a render now, and I'm going to get in close. So if we do a render, actually let's go to the save layout. Okay, where Maya puts them is in the render data directory. So let's just go ahead and look at where that is. Local disk. Okay, so I'm using this is my current project, Rendering 4.0. So I will find them in the render data, and they'll be in the depth directory. Okay, so it looks like I've actually been writing a couple of them out already, and just in previous renders. So I'm just going to view those as a list. And actually, I'm just going to change the name here. So you can actually name these. Okay, so I'm calling it Kathy Map. Do a render, and into the render data directory. So here is the first intersecting surface and the second intersecting surface. So we can actually look at those in FCheck. So by double clicking on them and just hitting the Z key. Okay, so that's one, and that's the other one. Okay, so now what you could do is you could then reuse those so that Maya doesn't have to recalculate them for every frame. So instead of using disk-based depth map, so we've written them out, now we're going to reuse them. Okay, and we're just going to type in the name of the depth map that we want to use. Now this is actually unsuitable, or this workflow is going to be unsuitable if you have a moving object or a light is moving, because the shadows will actually need to change from frame to frame. Okay, next thing I'm going to talk about is the Auto Render Focus button. And I'm just going to grab a file for that. Okay, so what I've got here is I've got a big plane, and obviously an ambient light and a directional light, and two spheres. Just make sure that the directional light has the cast shadows flag, or excuse me, has the use depth map. Okay, so it does. And let's just do a render. Okay, and I'm just going to save this. Let's move in a little closer and save it. Now if you look at the quality of the shadow for these two spheres, you'll notice that it's very blocky and not very good at all. So what most people will do is they will go in to the depth map shadow area and start turning up their depth map resolution. Now this is probably not the most optimal way to go, because what you're doing is you are, instead of using a depth map that's 512 pixels by 512 pixels, it will be, you know, if we make this 1024, now it's going to be 1024 pixels by 1024 pixels, and it's going to take a lot longer to calculate the depth map itself, and therefore your render time is going to take a lot longer. So this is not the most optimal way to go. The most optimal way to go is to actually turn off the cast shadows flag for the plane. So I'm just going to do that through the hypergraph. Okay, so there's the NURBS plane, and I'm just going to go into the render stats. And the cast shadows flag is on by default for all objects. So let's just turn that off, and let's do another render. Okay, so you can see how the quality of the shadow has improved a lot just by turning off the cast shadows flag. Okay, now the reason that it's a lot better than this version is because of the Use Depth Map Autofocus flag. This is also on by default. And what that does is Maya tries to keep that depth map tightly focused only around the shadow casting objects. So in this image here, the depth map was being stretched to include the very large plane. So we're not getting a very good accurate shadow with that. Now when I turned off the Cast Shadows flag for the plane, now the depth map's only really focusing around the two shadow casting objects, the two spheres. And you can see the shadows are much more accurate there. I just wanted to point out as well, with regards to shadows and using the IPR, you'll notice that the interface is divided into two sections here, this section here, and then this lower section. That's done for a reason, and the reason being that anything that's up in this area, you will actually have to re-render or recalculate, so you won't be able to use the IPR with it. Whereas anything down here, you'll be able to create a swatch and then just update the IPR with that. Okay, so the next thing that we're going to talk about is the ray trace shadows. And the reason that we use ray trace shadows specifically is to get nice colored transparent shadows that we can't get with a depth map shadow. So if I create, I'm just going to go to the work area. And I'm just going to map the transparency channel with a checkered pattern, okay, and just assign it to our sphere. Now currently, if we look at our lights here, I'm using depth map shadows. So let's just go ahead and do a render and save that render, okay. And let's just use ray trace shadows, and we should be able to see a marked difference. So use ray trace shadows. Remember to turn on ray tracing in the render globals, and oops, do another render. Okay, you can see that ray tracing is taking a little bit longer, but the shadow is much more accurate. Okay, so we're capturing that transparent information in that shadow. So that's one of the most important reasons for using ray trace shadows. Another one is also shadow attenuation. So as a shadow becomes further from the source, from its object, it actually becomes a little bit more hazy around the edges. So it would be like sharp around here where it's close, and then kind of fuzzy around the edge here. With Mental Ray for Maya, you do have the option to use depth map shadows. So if we just select the light here, and just under the attribute editor, under shadows, you can turn that on, and Maya's depth map shadows will render using the Mental Ray for Maya renderer. If you want to use the Mental Ray for Maya shadow maps, you'll need to leave this on and just scroll down into the Mental Ray section, Shadow Maps, and just turn that on. Okay, and now you do render, and you'll have a shadow map. Now, like Maya, there are two different kinds of shadows in Mental Ray for Maya. There's the ray trace shadows, and then there's the shadow map, which is a lot like the Maya depth map shadow. If we look at the attributes that are available under the shadow map, you'll see resolution, and that's the exact same thing as the resolution in Maya. So the square grid of pixels that's placed in front of the light at render time, or excuse me, before render time to get that sort of depth value that we talked about earlier. And then the softness attribute is exactly like the depth map filter size. So it's going to give you a nice soft edge shadow map shadow. Samples, what that's going to do is alleviate any kind of artifacting that may happen. For instance, if you do increase your samples, you might see a little bit of artifacting around the edge. So you'll need to increase the samples here. Okay, the more you increase the samples, the longer the render is going to take. The other option is you can take the settings from Maya. So what it's going to do is take the resolution and the softness, or the depth map filter size sampling from Maya, and use that if you want. The shadow map file name, like Maya, we can actually reuse the shadow maps in Mental Ray for Maya, and it's quite easy to set up. What you'll need to do is first go to the Render Globals, and just under the Mental Ray tab here, under Shadows, make sure that Shadow Maps is on, first of all, which it should be on, and make sure that Rebuild Shadow Maps is turned off. Okay, so we're going to reuse the shadow map. We don't want to rebuild the shadow map for every frame. So just make sure that's off. And then just under the shadow map file name, we'll type in a name here. So we'll type in test, okay? And then what we're going to need to do is generate that shadow map. So we're going to need to do an actual render. Okay, so that's not looking very good. So what I'm probably going to need to do is increase the samples. But because I want to show this very quickly, I'm just going to change the softness to 0. And let's try that again. And I'm just going to change the resolution to something lower as well. So we'll just do a render. Okay, so now, your shadow map file name test. If we want to actually see that, what's happened is it's actually written out to disk. So if you want to see where that is, just go into your current project directory. Currently mine is render DVD, but under the sort of directory structure here, you'll notice that there's a mental ray folder. And if we just open that up, this is where all the mental ray information is going to be kept. So if I do a render, a mental ray render, the information is going to be kept in the images directory. If I wanted to reuse a photon map, and we'll talk about that a little bit later, that photon map is going to be written into this directory. And the shadow map, if I just open up, is actually kept in the shadow map directory. So that if we were to move this object, just to make sure that this is working, that shadow shouldn't change. So we'll just keep that image. Okay, so you can see that even though our object has moved, the shadow hasn't. So it is reusing that shadow map. And again, this is it's a feature that helps speed up renders so that we're not actually recalculating that shadow map for every frame. Something else that the mental ray render does that the Maya render doesn't do is allow for motion blurred shadows. So I'm just going to open up a file here. Okay, and it's a very simple scene. It's a sphere, and I've actually already animated it. It's animated between 1 and 30, so we'll go about midway to frame 15. It's on a plane, and so let's just do a render. So you can see I've got some kind of shadow information there already. So let's have a look at our directional light. Okay, so we've got, let's see, we might be using depth map shadows here. Yep. So what I'm going to do is just turn on the shadow map. And in order to get the motion blurred shadows, I'll need to go to the render globals. It's going to change the render using to mental ray. Okay, because this is actually a feature that's not available in the Maya renderer. Go under the mental ray tab, and first thing we're going to do is turn on motion blur. So I'm going to use a simple motion blur, the linear type of motion blur. And I'm going to exaggerate the blur. So I'm going to do that by just turning up the motion blur by option to 3. And then just under the shadows section, what we're going to do is just make sure, again, that shadow maps is on and that the motion blur shadow maps option is also on. Okay, so I can't remember if I saved this. Save that, and let's do a render. Okay, so you can see this is the original image. Just look at the shadow. You can see it is a little bit longer. Okay, and if you wanted to kind of soften that up a little, give it a little bit more blur, what I would suggest doing is coming into the directional light under the shadow maps, and you might even just want to change the softness attribute here. So we'll go 0.025. Do a render. And we may need to actually increase the samples as well. Okay, and you'll notice that as we start increasing the samples, the render time is going to take a little bit longer. Okay, just to briefly go over in the render global some of the shadow methods. Off means no shadows whatsoever will be rendered. Now this is handy for quick render tests, things like that, where we don't need to have the shadow information available. The simple method, this is the default ray trace shadows option. Shadow sort. These three, I should mention, the simple, sort, and segments are actually ray trace shadow options. So this is the default. The sort, if there's a custom shader that requires this, you would use this. Otherwise, it's basically the equivalent of simple, except it's less efficient. And then segments, this is the most sophisticated way of calculating shadows out of the three. And this is used for things such as volumes, things like software rendered particles. So, you know, any of our software rendered particles, if you want, for instance, a cloud to cast a shadow on a ground correctly, you'll most likely have to use this segmented type of shadow method.